Hi everyone, my name is Miriam. Today we are going to talk about the forest in Point Pleasant Park, also known as Amitukaapi. Our research conducted by me and my team, Elsa and Patrice at Dalhousie University, looks at how the forest has changed over the last 20 years. We will explore how different plants interact and adapt to changes in their environment. This study helped us to understand the importance of protecting our natural spaces and how we can manage them better in urban areas. We are discussing our 20-year study of forest succession in Point Pleasant Park, or Amitukadi, which means birthplace in Mi'kmaq. This 75-hectare urban forest located on traditional and unceded Mi'kmaq territory in Halifax contains rare old growth Acadian forest fragments that have been significant to indigenous peoples for generations. On September 29, 2003, Hurricane 1 dramatically altered this landscape as a Category 2 hurricane with the winds reaching 155 km per hour. It destroyed approximately 70% of the park's tree canopy. This devastating event forced an 8-month park closure but created a unique opportunity to study urban forest recovery and succession patterns. Our study explores two competing hypotheses. Our null hypothesis suggests that the forest will undergo complete recovery through secondary succession, retaining to its original Acadian forest composition. However, our alternative hypothesis suggests that complete recovery is improbable due to ongoing natural disturbance and urban pressures. Our objectives: we are documenting post-disturbance forest dynamics to understand succession patterns in an urban context and predict future forest composition. This research has important implications for public health through urban air quality, ecosystem services, and climate change resilience. Importantly, we are also considering the cultural significant preservations for this space, integrating traditional ecological knowledge into our understanding.
Methods. For this study, we collected data from 6 forest plots in Point Pleasant Park, Nova Scotia, established in 2004 after Hurricane Juan, which caused significant disturbance to the forest structure. Data was collected annually to examine the effects of succession and disturbances on forest composition. The tree data included identifying all trees with a diameter at breast height. This was measured at 1.37 meters above ground using a measuring tape. The density of each tree species was recorded to assess the changes in tree population and structure over time. The ground flora was assessed by estimating the percent cover in 12 randomly placed 1 meter square quadrats per site. Ground cover estimates were done by consensus within the field group. Linear regression analysis was used to examine trends over time for metrics such as total tree density and species richness. R-squared values and p-values were calculated to determine the strength and significance of these trends. These methods were selected to understand long-term changes and predict future community dynamics. We will now be discussing our results. How has the overall forest community changed over time? Why? What can you predict will happen to the overall community as the forest moves towards its climax community? Why? The overall forest community in Point Pleasant Park has changed significantly from 2004 to 2024. Tree density has steadily increased, reflecting growth and species establishment, while average tree size has decreased, suggesting a higher prevalence of younger trees. This is due to both natural succession and external disturbances like hurricanes, which have periodically reset parts of the forest, creating opportunities for new species to establish. As the forest moves towards its climax community, competition for resources will likely intensify. Tree density may stabilize or decrease as smaller species are outcompeted by larger, more dominant species. Additionally, the diameter at burst height of the remaining trees will likely increase, reflecting the maturation of dominant species. Diversity may also decrease slightly as the forest structure becomes more homogeneous, favoring well-adapted climax species. This study aimed to examine how the forest community's diversity has changed over time. The key question was, how has the overall forest biodiversity evolved from 2004 to 2024? The study used Shannon diversity to quantify species diversity each year. A regression analysis was performed on diversity data collected between 2004 and 2024 to determine trends. In Figure 1, the data shows the regression line indicating the relationship between Shannon diversity and time. The study was done in Point Pleasant Park after Hurricane Juan from 2004 to 2024. The results reveal a positive trend in Shannon diversity over time, indicating that species diversity has generally increased over the 20-year period. The increase in diversity suggests that the forest community is undergoing recovery and succession, leading to greater biodiversity. As the forest moves toward its climax community, diversity may stabilize or decrease slightly, reflecting the establishment of dominant species in a mature and stable ecosystem. The Shannon diversity in 2024 was significantly higher compared to 2004, indicating a substantial increase in species diversity over the 20-year study period, as measured by the Shannon Diversity Index.
Shown in the slide are the summary paragraphs for both red maple and red spruce. Since 2004, the density of both red maples and red spruces has increased. Red maple density has increased by 79 times in 2024 compared to 2004, with a mean of 39 trees per 400 meters squared. Red spruce density has increased by 2.7 times in 2024 compared to 2004, with a mean of 9 trees per 400 meters squared. Red spruce, the dominant species in 2004, has increased in density but is no longer the distinct dominant species per 400 meters squared. Red maple has become the most dominant species in 2024, hosting the largest number of trees per 400 meters squared. Two graphs are shown here detailing the increase in dominant species density from 2004 to 2024. Red spruce is shown on the left and red maple on the right.
Based on our linear regression analysis, the equation shows a relationship between species richness and years, with an R value of 0.61. This indicates that 61% of the variation in species richness is explained by changes over time, with a degree of freedom for the regression as 11 and 84 respectively. Our p-value is far below the typical significant level, p less than 0.05, allowing us to reject the null hypothesis, which states that species richness doesn't change over time. And instead, our findings support the alternative hypothesis that species richness has changed significantly over the years. This outcome suggests potential ecological factor influencing biodiversity trends. Now, focusing on how this community metric has evolved and what we can predict as the forest approaches its climax community. First, let's look at the metric change over time. We have observed that species richness has increased over the years. This increase is likely attributed to natural succession processes and gradual ecosystem recovery in the park. As disturbance diminishes and the environment stabilizes, more species can establish themselves, contributing to the rise in biodiversity. Now, we can predict as the forest moves towards its climax community based on ecological principles. We anticipate that species richness may stabilize or even slightly decrease as the forest matures. This is because climax communities tend to support a smaller number of highly specialized species that are well adapted to the stable conditions of a mature forest. As a result, the fluctuations in species richness tend to reduce over time.
Based on our data, we predict that the Acadia forest of Point Pleasant Park is in the mid to late stages of succession to become a mature Acadia forest. Later stage succession species in Acadia forest include the red spruce, whereas early stage succession would have a more dense population of white spruce and great birch. The significant presence of red spruce in our 2024 data confirms the mid to late stage succession. Point Pleasant Park is an urban park which can significantly affect the natural succession rates. One way in which humans may affect the natural succession is via the cleaning of woody debris after the destruction of Hurricane Juan in 2003. A study showed that the removal of woody debris after the hurricane had a negative impact on soil fertility, reducing the forest's natural succession capabilities. An additional way for humans to affect the natural succession in the Acadia forest would have been to plant mature trees during the early stages of the succession right after the hurricane. Using two-eyed seeing, we may also gather knowledge on how certain species at different points in succession interact based on generational information from the Mi'kmaq Nation. We may use this knowledge, along with Western processes, to safely and respectfully protect the Acadia forest in Point Pleasant Park. We would like to give a special thanks to the following people and departments: the Department of Biology at Dalhousie University, Allison Schmidt, Kaylin Collins, and all current or prior students of Biology 2060.